So, using a phase diagram to predict phase at a given temperature and pressure. On a phase diagram, the y-axis is the pressure and the x-axis is the temperature. So we just need to find the pressure, temperature conditions that are being described, use a line from the x and y-axis for each of those two parameters, and work out if we are in the solid, liquid, or gas zone of the phase diagram. Complications may arise if, for instance, we have to convert between Celsius and Kelvin or pressure units. So let's break this question down. So suppose a small sample of pure X is held at 80 degrees Celsius and 0.6 atmospheres. What will be the state of the sample? So if we look at the y-axis for atmospheres, we can see each of these minor checks is going to be 0.1, right? 0.4, 0.5, 0.6, 0.7, 0.8. So 0.6 in terms of pressure, 0.6 atmospheres is going to be here. Okay, the temperature is 80 degrees Celsius, which gives us a bit of a problem because we need to convert that to Kelvin. So 80 plus 273.15. I'm going to be real with you. I'm not sure how accurately I'm going to be able to read off the scale to 273.15, but that would be 353.15 Kelvin. So looking at the scale here, it looks like each of those minor check marks is to the nearest 50. So 350 is here. 353 is going to be a tiny amount past, like it's literally going to be just past that line. So where the line for 0.6 atmospheres and 353 Kelvin meet is going to be definitely in the liquid zone. So we'll say that X is a liquid under these temperature pressure conditions. All right, so next part of the question, suppose the temperature is held constant at 80 degrees Celsius, so that's 353 Kelvin, but the pressure is decreased by 0.5 atmospheres. What will happen to the sample? So I'm going to get a different color here. So if we decrease the pressure by 0.5 atmospheres, each of these minor checks is 0.1. So 0.5 atmospheres, if we're keeping the temperature the same, is 0.1, 0.2, 0.3, 0.4, 0.5 will take us down to here. Or alternatively, if you wanted to, you could take your starting 0.6 atmospheres minus 0.5 for how much it's been reduced by, which leaves us as needing to draw a line across from 0.1 atmospheres. So 0.1 atmospheres would be on this scale down here. So this is the same point where we are intersecting with the line here. So this is the new point we're looking at, okay? So this is now in the gas zone, okay? So what will happen to the sample? Gas doesn't make sense, right? What will happen to the sample? It will boil. So the transition that we have crossed, sorry, is the transition line between the liquid and gas phase boundary. So liquid going into a gas is boiling. All right, so then the last part of this question, I'm going to have to scroll down a little bit. Suppose, on the other hand, the pressure is held constant at 0.6 atmospheres, but the temperature is decreased by 162 degrees Celsius. Okay, so we have a decrease in temperature of 162. So remember, the temperature was originally at 80 degrees Celsius. So minus 162 is going to give us a negative number in degrees Celsius. Okay, so that is going to be minus 82 Celsius. If we want to convert that to Kelvin, minus 82 plus 273.15. It's going to give us in Kelvin. Again, I'm not sure how accurately I'm going to be able to read this. 82 minus plus 273.15 is going to give me 109.15 Kelvin. So let's find where that temperature line is. I am going to have to scroll down again. What will happen to the sample is what we're looking at. So let's get this back. So this was on my 0.6. Then my new line, so I'll use a new color, is going to be at 109.5. So it's going to be a little bit after the 100 line. Okay, so we've decreased the temperature at the same pressure, so 0.6. So we were here at 0.6 and 80 degrees Celsius or 350 Kelvin, and we have now gone to this point here. So we've crossed the liquid to solid phase boundary. So a liquid going to a solid, we would commonly say it will freeze. Okay, so that is the kind of thing you're looking out for. Make sure if you need to convert temperature into kelvins that you do, and just read the question carefully, as in what the current pressure and temperature is, and if you're changing pressure or temperature, and then just travel along the isotherms if the temperature is being kept constant, or iso bars, I guess, for the same pressure, right? So just use those lines to help you determine whether you cross a phase boundary or not. If you don't, then nothing happens, right? If you heat up a liquid and you don't cross those phase boundaries and you're still in that liquid zone, then you still have a liquid. So you just have a warmer liquid, let's say. Okay, so hopefully that helps.